Properties of logarithms. Here we will talk about the product rule, the quotient rule, the power rule, how to expand logarithmic expressions, how to condense, make smaller into a single unit, logarithmic expressions, and then apply the change of base property or formula. Here, the product rule, and these rules that we will discuss here for logarithms are based on the laws of exponents. And so we have what's called the expansion property. That's the product rule, that the product of log base b of m times n is equal to log base b of m plus log base b of n. We can expand if two terms or more than two terms are multiplied. We can expand them. Here, notice the property from exponents. So we're looking at this m and this n, and here the whole term is being multiplied. So here you see the product, right? So that's the idea. And then over here, you see the plus sign and the plus sign there. So the property from for the logarithms comes directly from the property from the laws of exponents. And you can also go in the opposite direction. That is that if you have log base b of m plus log base b of n, then that is the same. From this expansion, we can condense. This is the log of base b of m times n. So you can read it from left to right or also from right to left, and we still have equality. The quotient rule, it's this statement here that the log base b of m divided by n. Here, when we expand that, this quotient rule for exponents, well, for logarithms, excuse me, is based on the quotient rule for exponents. You see, here we have a division, and this is b to the m divided by b to the n. And then on the right side, notice there that the exponents are subtracted. And so this minus here represents that minus there. And so how do we deal with the product? It becomes the sum for logarithms. And how do we deal with division? That becomes subtraction. Do you see that? Okay. The so-called power rule. If we have a power raised to a power raised to a power, you multiply the powers, right? So when an exponential expression is raised to a power, we multiply the powers. So that's what's happening here, that we have m raised to the p. Well, that's the same thing as p times, right, this logarithmic expression. So that's the idea there. And so 1, 2, and 3, we just got through stating. And then they take these same properties and just read them from this side to that side. And so you have these statements here. And then the last thing in this section is the change of base. What base are we talking about? We want to change from B to A. If B is a base that we cannot calculate on our calculator. So here, if B is anything other than 10 or E, then use here the change of base property. Okay, and so it's a formula, and we just use it directly. If I have log base b of m, then that's going to be equivalent to log base a. We're changing the base changing bases. So especially for our baseball, softball players, we're just changing the bases. So this becomes log base A of M divided by log base A of B. Both bases here for the change say the same, base A. And so what goes on top, this number here, and what goes on the bottom, B, right? So just a way of kind of, to yourself, remembering what this stuff is. Well, let's look at some problems. Use properties of logarithms to expand each logarithmic expression as much as possible. So we're going to expand out, and where possible, evaluate logarithmic expressions without using a calculator. So we're going to expand this out just based on the properties. Remember, we have log base B of M times N is the same thing as log base B of M plus log base B of N. So applying that, we have here this log base 11 of 11 plus log base 11 of X. Now, notice we have a neat property for this recall. If we have log base B of B, you remember that we said that this was equal to 1. So this becomes 1 plus log base 11 of X. Okay. So for this one, this is that quotient. The quotient becomes the subtraction. This is log, and if there's no base, is understood, if it's log, understood to be the common base of 10. So this is log of y minus log of 1 million. And so this is log base y, log of y, minus, look at this, this is log base 10 of 10 to the count to 0, 6 power. Remember that property. So this is log of y minus 6. And I better write it correctly so we don't get confused. This is negative 6 plus log of y. You probably better put that in the calculator, because over here, you don't want to get confused by looking at this. It's not supposed to happen. See, that 6 minus 6 has nothing to do with y. It's not log and then y minus 6. That's not what it is. It's negative 6 plus log of y, right? So this is the natural log of e to the second minus the natural log of 11. But remember, natural log and e are inverses. And then this is the multiplier. This is the power becomes the multiplier, right? You have log base b of, say, x to the n. That's the same as n times log base b of x. And the natural log of x to the n is the same thing as n times the natural log of x. But the natural log of e, this guy right here, is just equal to 1. So this is 2 times 1 minus the natural log of 11. So your answer is just 2 minus the natural log of 11. And better to put the 2 in the front and wouldn't write it as minus the natural log of 11 plus 2, because you don't want to get the 2 associated with the 11, because they're two different terms. They're unlike terms. So we're expanding. Let's look at what this is. This is the natural log of x to the 1 over 15th power, right? That 15th root. But that's the same thing. If it's a power, I can multiply, right? So this becomes a multiplier. The power becomes a multiplier times the natural log of x. That's it. Expand here. So this is log base b of z squared plus log base b of x. But you want to keep on going. We have this power. The power of that 2 becomes a multiplier. 2 times log base b of x plus log base b, that's z. Yeah. All right. So that's what it means to expand. Here we're going to expand some more. So this is log base d. Now everything up top, this is the square root of a, and then this becomes plus log base d of b to the 5th, and then minus log base d of c to the 7th. See that? If it's multiplied, the product becomes the sum, and then the quotient becomes minus, right? So you got a lot going on there. So you had to make use of 2 properties. We're going to make use of all 3 of them, but that's the log base b of, I'm just going to write it as x times y. That's the same as log base b of x plus log base b of y. Then the second one is log base b, let's just say x over y. They use m and n. I don't like those unless I'm eating M&Ms. Anyway, this is log base b of x, that becomes minus log base b of y. And the third one we got to make use of here because we have some powers is log base b of x to the n is n times log base b of x. So go back and look at that problem. Now this is the square root, that's a to the 1/2 power. So that becomes a multiplier of 1/2 times log base d of a, plus that 5 becomes a multiplier of log base d of b, minus that 7th power becomes a multiplier 7 times log base d of c. That's the answer. You're going to put that there in my math lab or whatever they call it. All right, some more expansions. I'm like, enough already, right? So anyway, this is log base 4. Now that whole thing is raised to the 1/5 power. So let's make sure we see that. This is x to the 6 times y over 16, and that's raised to the 1/5 power. So I'm going to get rid of that 1/5 power by making it a multiplier. So this is 1/5 times log base 4. And that's the x to the 6 times y over 16. Now, if it's product, I'm going to add, and then if it's division, we're going to subtract. But watch how we do it. Make sure you get it right. Now, this is all times 1/5. So 1/5 times brackets log base 4 of x to the 6 plus log base 4 of y. Now it's division minus log base 4 of 16. Now we can simplify that because here I got that power of the 6. So this becomes 1/5 times 6 times log base 4 of x plus, thought I was going to write a minus, huh? Base 4 of y minus, now watch this, this is log base 4 of 4 to the 2nd. That's 16, right? So I'm going to run the 1/5, multiply that through. Now you know that log base b of b is equal to 1, and is log base b of b to the x is equal to x. So this whole guy over here is just 2, right? So I get 6/5 times log base 4 of x plus 1/5 times log base 4 of y minus, that's going to just be 1/5 times 2, but I want you to see it. This is 1/5, and this is, I'm going to put that in there, times 2 times log base 4 of 4. And log base 4 of 4 is just equal to 1. So this is just 1, right? And that was a property that we had back in the previous section. That is log base b of b is equal to 1, and log base b of b to the x is equal to x. So that's just going to give us 2. That's just 2 times 1, we still get 2. And that's the cool thing about these properties, is that they don't collide with each other. So the answer is 6/5 times log base 4 of x plus 1/5 log base 4 of y minus just 2 times 1/5, or just 2/5. And you can probably put that minus 2/5 out in the front so that this minus 2/5, nope, the minus 2/5 is not confused with that y, right? We're going to get it right one of these days. Now, so we're going to go the opposite direction. Now they're going to be expanded. Now they want us to condense, try to make 1 unit. So this, if it's plus, that means we multiply. So this is the natural log of 13x. Nobody says x times 13. Nobody says x 13th. You say 13x, right? You can put it in parentheses if you want to. This is minus, so it's going to be division. So this is log. If there's no base, that's a common base of 10. So we don't have to write it. So this is 3x plus 10 all over x, right? Put it in parentheses if you want to. You don't have to. All right? So we're going to condense, and then it says write the expression as a single logarithm, use coefficient, whose coefficient is 1. All right? What does the heck does that mean? Who knows? All right, so I can't do any adding until these multipliers become powers. Okay? Just can't say this is going to be some log whatever times. Can't do that. I have to write this first. This is log base b of x to the 4th plus log base b of z to the 8th. Now, I can convert this plus to the log of the products. So this is the log base b of x to the 4th times z to the 8th. That's the answer. But you notice that we didn't make it a product before we first dealt with those multipliers out there in the front. I had to get those multipliers and take them upstairs. See that? Okay, more of the same. This is natural log of x to the 3rd plus the natural log of y to the 6th minus the natural log of z to the 2nd. Now, if it's plus, it becomes multiplication. If it's minus, division. So I have just 1 unit. This is the natural log of x to the 3rd times y to the 6th. Minus sign means divided by z to the 2nd. Now, when it says 1 unit, I'm not writing natural log like 2 times. It's not natural log of something divided by natural log or whatever. Make sure you get that, because I see that. I've seen that in the past. Okay, you don't see me doing that. That's what one teacher used to say. Am I doing that? So why are you doing that? All right. So let's move on. Again, we're going to write as a single unit. We're going to run that 1/2 through. So this is 1/2 times, log, not natural log, log base 5 of x plus 1/2 times log base 5 of y. And then eventually we got to make the multiplier the power. This is log base 5 of x plus 5 to the 4th power. All right, so where we have these multipliers, we got to make those guys, convert them, take them upstairs and make them the powers. So this is log base 5 of x to the 1/2 plus log base 5 of y to the 1/2 minus log base 5 of x plus 5 to the 4th. Now we know that 1/2 power is the square root. So this is log base 5 of the square root of xy minus, just breaking it up, log base 5 of x plus 5 to the 4th. Now this becomes, the minus, write this as the quotient, that is the fraction. Log base 5 up top, the square root of x times y, all over x plus 5 to the 4th power. Okay. Recall, because, so this x to the 1/2 is the same thing as the square root of x. Right? So we multiply, it's plus, we multiply, it becomes x to the 1/2, right, times y to the 1/2. That's the idea. And this is x times y all to the 1/2, or the square root of xy. All right. Well, this one's for you. You can like pause the video, try to work it, and then see if you get what I get. So again, this 1/7 is multiplied to the entire expression. All right. So what I'm going to do is just put the answer, if I can see it. Oh boy. Let's see if I can just kind of put the answer there like how it ought to be. See if I get it right. So up top, I'm going to have this x plus 4 raised to the 5/7 power. And then downstairs, it's going to be that x times that x squared minus 9. All that is raised here to the 1/7 power. All right. Well, let's just work it out. And we'll just take the steps. So this is 5/7 times the natural log of x plus 4 minus 1/7 times the natural log of x minus 1/7 times the natural log of x squared minus 9. All right, so all the multipliers become power. So this is the natural log of x plus 4 raised to the 5/7 power minus the natural log of x raised to the 1/7 power minus the natural log of x squared minus 9 raised to the 1/7 power. Right? So here, the only thing that's up top is this x plus 4 raised to the 5/7 power. The minus drops downstairs. Minus drops downstairs. So we have the natural log of x plus 4 to the 5/7 all over. Now, once they get downstairs, there's a plus sign. This is x to the 1/7 times x squared minus 9 to the 1/7. Now, I mean, that's the answer. You can leave it as that. If you want to spicy, you can make it spicy. let's see, this is the natural log of, they all got 1/7 power. I don't know if you see that. Well, if you see that, then I'm going to just say this is that's the 7th root. Up top, x plus 4 to the 5th, all over. That's still inside. This is x times x squared minus 9. Again, if you just put that in there like that, if you can, grab all those items there in that legend box on the bottom there at My Math Lab to keying in the answer. You see the fraction button. It may have a button, something like that. And then they got buttons for the power, right? You use all that. All right, use the property of logarithms to expand. So if you got it, let's just write it out. Here's the answer. If it's plus, that means I'm multiplying. Minus, drop downstairs. Minus, drop downstairs. Two things drop downstairs. The sign becomes positive. So what I have is log, here this up top is x times x squared minus 4 all over 4 times x plus 2. Now, we would stop there. Let me go back and look at this previous problem, see if nothing was going on funny in that one. No, there's no common terms. X plus 4 is different than x squared minus 9. X squared minus 9 becomes x minus 3 times x plus 3. So nothing common there. I do have some commonality here. Dang gun it. This is x times, factor that x squared minus 4. That's x minus 2 times x plus 2 all over 4 times x plus 2. So the x plus 2's cancel. Steve Harvey says, give me red. Give me whoever's next on the Family Feud. So then we have log base x times x minus 2 all over 4. That's the answer.